Hi everyone, today's Java interview question is what is the internal implementation of concurrent hash map in Java? This is the one of the most frequently asked Java interview questions. So let's understand step by step. Let's take a overview. First of all, what is concurrent hash map? Think about a normal hash map. Hash map is very fast but it's not thread safe. If multiple threads modify it simultaneously, it can produce inconsistent data. On the other hand, hash table is thread safe because every operation in hash table is synchronized. But there is a problem in hash table. Hash table logs entire map for every read and write operation. Imagine a shopping mall with only one entrance. Even if people want to go to different shops, everyone has to wait in the same line. That's exactly how hash table works. Concurrent hash map solves this problem. Instead of locking entire map, it locks only the required bucket. That's why it provides high performance with thread safety. Concurrent hash map is a thread safe implementation of hash map that allows multiple threads to read and write data simultaneously without locking the entire map. Now look at the key ideas in this image. The first key idea is data is stored in a node of key and value array table. Think of it an array of buckets where each bucket stores one or more nodes. The second key idea is every bucket initially stores as a linked list. If too many elements are stored in the same bucket, Java automatically converts that linked list into a red-black tree to improve search performance. The third key idea is concurrent hash map uses a fine-grained locking along with CAS, compare and swap. Instead of locking the entire map like hash table, it locks only the required bucket. It allowing multiple threads to work on different buckets simultaneously. The fourth key idea is because of bucket level and CAS, concurrent hash map provides high concurrency with minimal blocking. That means multiple threads can access the map at the same time with excellent performance. Now look at the internal structure shown in the image. Internally, concurrent hash map store data inside a node of key value array table. You can think of it an array of buckets. Each bucket stores node objects. If only one element exists, the bucket simply contains one node. If more keys generate the same bucket index, multiple nodes are connected together. And when too many elements are stored in the same bucket, Java converts that linked list into a red-black tree. Why? Because searching inside a linked list is order of n and searching inside a red-black tree is order of log n. So Java automatically improves performance. Next, how put method works internally. Now let's understand what happens when we call map.put key and value. The first step is calculating the hash value of the key. That hash helps Java identify which bucket should store the data. Now there are two possibilities. If the bucket is empty, Java doesn't immediately lock anything. Instead, it uses something called CAS. CAS means compare and swap. CAS is a CPU level atomic operation. It checks whether the bucket is still empty. If yes, the new node is inserted immediately and no locking. That's why concurrent hash map performs very well. Now suppose another thread already inserted data into the same bucket. In this situation, CAS fails. Now concurrent hash map locks only that particular data. Notice this carefully here. It never locks the whole map. Only that bucket becomes synchronized. Then Java safely inserts or updates the data. This technique is called fine-grained locking. This is one of the most important interview keywords. Next is Treeification. Now imagine many keys generated the same bucket index. Initially Java stores them as a linked list. But when the number of nodes becomes more than 8 and the table size is at least 64, then Java converts that linked list into a red-black tree. Why? Because linked list search becomes slow and tree search is much faster. Now let's talk about resizing. As more elements are inserted, the data eventually becomes full. Instead of stopping all threads, concurrent hash map creates a larger table. then it gradually transfers data. During this transfer, Java uses a special object called ForwardingNode. Its purpose is simple. If another thread comes during resizing, the forwarding node tells to it whether the data has moved, so other operations continue smoothly. If size is greater than threshold, it initiates the resize. Default capacity is 16 and load factor is 0.75. Now look at the code examples. In first example, simply insert values and retrieve value using get method and remove an entry. These are normal operations. In the second example, multiple threads insert data simultaneously. Even when many threads work together, ConcurrentHashMap safely stores the data without corrupting it. That's why the biggest advantage over HashMap. And finally, interview answer is ConcurrentHashMap stores data inside a node array. It calculates the hash to identify the bucket. Each bucket is a linked list. If a bucket size exceeds threshold, it converted into a red-black tree. It uses fine-grained locking and CAS. CAS means compare and swap. ConcurrentHashMap reads lock-free, means non-blocking in most cases. And ConcurrentHashMap resizing is done by using a special forwarding node to help transfer data safely. Null keys and null values not allowed in ConcurrentHashMap. That's it. Please subscribe my YouTube channel for more Java interview questions. Thank you.